I wanted to give a quick tutorial on homework 1-3 as I typically get several questions about this problem. The reason I created this problem was I noticed a lot of students have less difficulty coming up with numerical answers than solving problems symbolically. And that is a problem for an engineer who often needs to work out a problem without any numbers before they actually have some data to work with. So although I understand your hesitancy sometimes to continue on with a solution when you don't have numbers to work with, but it is a very important skill to work with a system of equations. So the equation here is quite simple, really. It's the first law for a closed system. So that equation is, I can use drawing tool here, Q minus W equals delta E. So the heat transfer, if we have to define our system with a system boundary. So here is my system. And this is one of the most fundamentals concept of thermal 1. So, and then I have my surroundings. So when we apply the laws of thermodynamics, we're always applying it to a system, and we have some defined boundary. So everything inside my boundary is my system. Everything outside of that is my surroundings. And we have Q is always defined as heat transfer into the system, and W is defined as work out of the system. Now that doesn't always have to go in that direction. If we have Q out of the system, it's just negative. If we have work into the system, it's just negative. But those are the assigned values for the first law. And then we have the energy of our system, E. Now, in thermodynamics, we have 3 terms for energy. So energy would equal the internal energy, the kinetic energy, and the potential energy all summed together. Now, each of those, the internal energy has a definition. If we want to do it on a per unit mass basis, we can write that as the mass times the specific internal energy. If we want to look at the kinetic energy, that would be m times the specific kinetic energy. We use lowercase values. Now, Ke equals v squared over 2, where v is the velocity. It's a scalar value, but I put the little vector symbol over it just so we can distinguish it from volume. So it does have direction. And or we can say that Ke, capital Ke, equals 1/2 v squared. And the same thing, we have potential energy is mgz, where z is some elevation. Now, if we're talking about particular state, then we can say that we have, say, the internal energy at state 2 and the internal energy at state 1. So delta capital U equals m times the specific internal energy at state 2 minus specific internal energy at state 1. And we can do the same thing for kinetic energy and potential energy. So when I'm looking at delta E, I'm really saying that this is U2 minus U1 plus KE2 minus KE1 plus KE2 minus KE1. And then I can replace any of those with this equation for definition of potential energy. So mgz2 minus mgz1, and the same thing for the kinetic energy. So I can write the kinetic energy at state 2 is 1/2 mv2 squared minus, and then minus ke1, 1/2 mv1 squared. So I normally don't want to write out every possible expansion of all these terms. I want to be able to work with them as appropriate. So having those equations in mind, let's take a look at the first two questions. So enter the equation for ke2 given these variables that I can work with. So I have certain known values, and everything else can then be written in terms of those. So let's, even though in the answer blank, you won't put this first part, let's just put ke2 equals. So the kinetic energy at state 2. Well, the kinetic energy at state 2 would be most obviously defined as 1/2 mv2 squared. So the mass times velocity at state 2 squared. Now we do have the mass. We can always use constants in our equation. So 1/2. And we are not given v2. So we can't square it. It's not a given variable. So in that list here, we can only use these variables in our equation. We're saying that those things are known. So let's see, enter the equation for ke2. It's a little confusing here since I have the second question right after it. So let me just try to insert that there. Okay, it's a little confusing. That is currently B. Not sure what happened to your answer for A, but let me just put this down here. That makes a little more sense. Okay, so this is where I'll enter my answer. So I'm trying to find equation for ke2. The next question is, let's just get this one set up here below. Just it was a little strange the way it formatted when I copied it from the website. All right, so how would I find ke2 when I don't have v2 squared? So I'm going to have to come up with some other way. And so looking at these equations to the right, well, let's see what we have. Well, we do have the change dke. Now, dke is really delta ke. It's just difficult to type in a delta using the text input. So the capital D just stands for our delta symbol. So that is given. And delta ke is equal to ke2 minus ke1. And I am given ke1. So since I'm given two of those values, I can just simply solve for the third. So now I solve this equation for ke2. So ke2, which is what I'm giving an answer for, there's already an equal sign there. So I simply just put the right-hand side of the equation, which will equal delta ke, which is one of the given variables, plus ke1. Let's move on to the next one. That one wasn't too challenging. Enter the equation for V1. So I'm looking for an equation V1 equals. So V1 shows up in the kinetic energy for state 1. So we know that kinetic energy for state 1 equals 1/2 mv1 squared. So I'm trying to solve for v1. I'm given ke1, so I'm given this term on the left. I'm given the mass, so the mass is given, and 1/2 is a constant, so I just solve for v1. So I have v1 equals, I'll bring the multiply both sides of the equation by 2. So I have 2 ke1 divided by m. And then I need to take the square root of that. One way I can do that is raise it to the power 0.5. All right, let's see if we can put these, and that's not a check mark, that's a ke1. Let's see if we can enter these into the homework system. And so I'm going to go back. So I have delta ke1 plus k, or delta ke plus ke1. Now I'm going to write that as d ke plus ke1. And I'm going to submit that. And it says it's correct. Now, if you wrote it differently, if you wrote it as ke1 plus dke, let's say you even put times 3 minus 2, it would still evaluate to the same thing. 3 minus 2 is 1. 1 times dke is dke, and I'm adding ke1 to it. If I hit enter, it still says it's correct. So it doesn't matter how you put it in. You just can't violate the syntax of the way it's processing the text. So if you leave parenthesis off or do something like that, it will create an error. And depending on your browser, it'll probably do something like this. It'll just stop processing the page once it encounters those errors. So the best way to probably deal with that is just to go back. And you may have to resubmit the form, and you'll get back to what you had. So just know that even if you had answers after the one you're working on, they will seem to disappear from the page, but you don't have to do them all again if you use the back function on your browser and refresh it. You should get back the things you've typed in. All right, let's do the value for v1. So let's go back to our equation here. So we have 2 ke1 divided by m, all raised to the power 0.5. I'm going to put we'll try it both ways. 2 ke1 divided by m raised to the power 0.5. I don't remember if sqrt is a function here, but I don't think it is. We can try it, but this would be the safe way to do it. So we're raising it to the power 1/2. I'm going to press enter and see what happens. Okay, now this math processor is seeing that I have a number, and then following that number, I have a variable. It is allowing that. You're playing a little bit with fire here, so it would probably be better to go ahead and put the implicit multiplication there. So when you have a number in front of a parentheses, I added implicit multiplication. When you have a number in front of a variable, I have implicit multiplication. But if I wanted something like mg, let's say I wanted to divide by mg, and I put in parentheses divided by mg, and let's say I even put a g in the numerator, so times g. So 2 times KE1 times G divided by MG should be correct, but I believe I will get an error here. And the reason for that, and you'll probably see this strange thing showing up, is that it's seeing mg as a variable. It doesn't know that you meant m times g, because that could be the name of a variable mg. So you can't string two variables together without putting a multiplication sign between them. Now, if I put the multiplication sign in between them, it should work. Yes, except I am missing a parentheses actually. So that was two errors. I have only one closed parenthesis, so now it should work. And I may have to, I think at this point, go back. I'm going to try this new odd form of my equation. So m times g and times g. Now that is a variable that I could use. Now I'm just canceling it out. So the g is just kind of going along for the ride there, but it should still tell me the answer is correct. And yes, so I reevaluated, although that would be a strange way to write it. So I would not put in variables that aren't needed. And the simplest correct form of this would just be 2 times KE1 divided by m, all raised to the power 1/2. All right, I hope that helps you. Some of these get a little challenging. You'll have to kind of piece all these equations together. But now you can see how to enter it. Don't put the equal sign in there. Don't type in KE2 equals. So it's just saying your answer for KE2. So this is really saying KE2 equals, and then this is the right-hand side of the equation. The only variables you can use in your expression are the ones listed here. And I believe they stay the same for the whole problem. So they're listed at the top. I just wrote it that way so that in the future, if I wanted to change the given variables, but I believe right now that they're all the same. All right, I hope you have success with that. I do not think the help function works for this one. So if you get stuck on one, you'll get a 0 for it. So keep trying. And if the page disappears for an error, just go back and refresh, and you should get back all your previous values.